Hey everybody, and welcome back to another session from Net Academy. What we're going to be covering on this week's video is actually quite a lot of detail. We are going to be going into the different OSPF area types. There's actually 5 different OSPF area types. You've got the normal, the standard type of OSPF, and that is pretty much everything we've seen so far. You've then got another 4, and these are really the more special areas. We've got stub, totally stubby, not so stubby area, and then totally not so stubby area. And not so stubby area is abbreviated to NSSA, and you hear me saying that a few times. So we're going to cover what are these areas actually for? What purpose do they serve? Why do we actually need them in the first place? What benefit do they bring? And then carrying on from the last video, we're actually going to go into the OSPF LSA or Link State Advertisement Type 7. We're going to go into where do you see this LSA Type 7, i.e. relating back to the OSPF special area types. We're also going to go into how to configure the virtual MX routers to be an NSSA or totally NSSA, so we can actually see those Type 7 LSAs being transmitted and received. And we're also going to cover where the boundary actually starts and stops for those Type 7s, because they're not forwarded from one area to another area. We need to identify, well, if they just stop at a specific boundary, what takes its place and why is that? So let's get going. Okay, and here's the network that we've actually been building for the last few weeks. We've got area 0, which is the backbone or transit area, where really only VMX1 resides in, but of course VMX2 and VMX3 reside in there as well, but they're ABRs, so the area border routers for area 2, area 3 respectively. And over the last few weeks, we've configured area 2, we've configured area 3, we've gone into the different LSA types, types 1, types 2, types 3, types 4 and 5, i.e. the router LSA, the network LSA, the summary LSA, the ASBR LSA itself, and then the type 5 external LSA. And this week, as I said, we're going to cover those different OSPF special area types and the LSA type 7. Now, as I said, there's 4 special types of areas. Yes, there's 5, one being the standard, but the others are the stub, the totally stubby or total stub. Then we've got our not so stubby area. I'm just going to abbreviate that again to NSSA, so not so stubby area. And then we've got our totally not so stubby area. So why in the OSPF world do we need these different types of OSPF areas? OSPF is a really great protocol because not only do the areas serve to minimize broadcasting, minimize flooding, minimize the actual disaster area, God forbid, if something should happen on the network, but what the areas allowed to do themselves is, if you look at it from a router's point of view, a router has a certain amount of processor, of memory, of actual capabilities. And if a whole network was one big gigantic area, then those real high capable, high cost routers, they're probably going to be okay with a large network if all the network was in a specific one big area. But for those lower performance, lower cost routers, they're going to struggle a bit more because their processor, their memory isn't going to be as capable. So having the capability to divide as such the network into different areas, and of course having that backbone, the transit, area 0, allows us to segment, to control the network independently within each area. But there are of course some areas where you don't want all these routes advertisements being advertised to and from different areas. So if we look at VMX4 in area 2, it might be a lower cost, lower performance router. Its CPU, etc. might not be as capable as VMX1 in area 0. And so would it want to receive the hundreds or maybe thousands of LSAs and to put all of that information into its link state database? Would it want to receive all of that? More than likely, no. because again, that's going to impact that router's capabilities. So having the ability to define different OSPF special areas, as I call them, or OSPF area types, allows us to control the different types of LSAs that are imported and exported into these specific areas. And that's what we're going to cover. So the real benefit of having these different types of OSPF areas is that we are, again, controlling what goes into and out of these special areas, whether it be stub, totally stubby. That, you know, there's going to be LSAs that are allowed and some LSAs that aren't allowed. But also it then means that those lower cost, lower performance routers, their CPU, their memory isn't being impacted, and they don't have to install these hundreds or thousands of link state advertisements into their LSDB and maybe into the actual routing table. So what is a stub network? Well, a stub network is a network where you want to receive types 1 and 2. As you recall from previous videos, types 1 and 2 will always be sent and received in an area and not advertised outside that area. And so really for all these OSPF area types, you are always going to have types 1 and type 2 LSA. Absolutely. Regardless whether it be area 0, area 2, area 3, you're always going to have a type 1, type 2. And by the way, area 0 cannot be a stub or totally stubby or not so stubby area. You cannot configure area 0 to be that because it is the transit area, just so you know. But if we come back to the stub area itself, it is then going to start saying, well, I'm going to allow, maybe not allow some LSAs to be imported into my area. So it is going to allow a type 3 summary LSA. So if we've got 100 routes being imported into area 2, which is a stub LSA, it will then, the ABR VMX2 will then summarize those 100 LSAs that it's received into 100 type 3 LSAs and import that into the stub area, i.e. area 2. But it will not allow types 4 and types 5 and type 7. These are not allowed in a stub area. Okay, so you do get types 1, types 2, types 3, but you do not get type 4, you do not get type 5, you do not get type 7. Okay, totally stubby is almost the same. Here though, they say, well, in the totally stubby area, maybe I don't want to receive these hundreds or maybe more of type 3 LSAs. Maybe actually just injecting a default route from the ABR into this totally stub area itself, saying for all external networks, which could be via the type 4, type 5, so external networks to OSPF, or the summary LSAs, type 3s, I'm just going to have that one default route which will advertise everything to me. It's default, and so I will send all my traffic to that one ABR. So in a totally stub area, you get types 1, types 2. You also get that default route, but you do not get types 3, types 4, types 5 running out of space, and type 7. Again, they're gone. You're not going to get that in a totally stub area. Not so stubby areas though are a little bit different. Okay, the reason why that bit is because if area 2 is a not so stubby area, if this is now an NSSA, it is not allowing types 4 and 5 both into the network here and into the network here. Okay, that might be fine for area 3, but if we look at area 2, we could see we're actually importing static routes into VMX6 into OSPF. We're taking these static routes and we're importing that into the OSPF routing protocol in area 2. And how will those static routes be advertised throughout area 2? They're going to be advertised as type 5s. And then the ABR, as we discussed in the last video, will advertise these as type 4s moving onwards. And of course the type 5s move on from there as well. Now the NSSA or the stub area, I should say, the stub and totally stub networks, it breaks this rule. It says, well, if you are a stub area or a totally stub area, you are not going to transmit through me types 4 and 5. So then these static routes or BGP routes or ISIS routes, it really doesn't matter. It's a routing protocol you import into OSPF. How are these routes going to be advertised through area 2 into area 0 and down to area 3 if this was a stub area? The short answer is it's not possible, because the stub or totally stub area does not allow types 4 or 5 or types 3, 4, 5 and 7 to be actually transmitted through that area. So let me just clear the screen just a bit. And so now that I've got my screen cleared, let me just re-enter in here not so stubby area. What the VMX6 is going to do is, yes, it's still going to take these static routes in, or whatever routing protocol it might be, something that we want to advertise, an external network we want to advertise into OSPF, but it's now going to inject these as, you guessed it, type 7 LSAs. So VMX6 is what's known, and just for your refreshment, as an ASBR, an autonomous system border router. So an NSSA, tongue twister, an NSSA or totally NSSA area does allow type 7 LSAs to be transmitted from the ASBR throughout the area up to the ABR. But once that LSA type 7 gets to the ABR here, it's not going to forward that type 7 LSA into area 0, and then area 3 is not going to take in that type 7 LSA into area 3 via the ABR. That's not going to happen. What happens then is we pretty much go back to normal. The ABR VMX2 here will take in that type 7 and then advertise out a type 4 and type 5 LSA. So that ASBR summary LSA and that external network LSA respectively. So the type 4 LSA identifies to all the other routers where this ASBR, where VMX6 is actually located and the cost to get there. And the type 5 identifies the networks that are associated to the ASBR, the advertising router, and obviously their network ID, the subnet mask, etc. So that's really the difference between the stub, totally stub, the NSSA not so stubby area, and the totally not so stubby area. But if I just fill in the blanks down here, which I forgot to do, so the not so stubby area, you can get types 3 in here as well. So we will still get, coming into area 2, our type 3s, but we do not get type 4, we do not get type 5, but we now allow type 7 LSA. So here you can hopefully see the difference between stub and not so stubby area. And the totally not so stubby area, it doesn't allow types 3, doesn't allow type 4, and it doesn't allow type 5 at all. It also will inject a default route, just like we saw with the totally stub area. So instead of these hundreds or thousands of summary LSAs, the type 3 LSAs coming into that area, now we're just going to advertise one default route, maybe to the internet or to those external networks with a specific metric type, saying, if you want to get to these networks, whatever it may be, come through me. But now we also get that type 7 LSA. We're going to go to more detail into these OSPF area types. We're going to use an example on next week's video, but just for your information, these are those 4 special, as I call them, or those 4 OSPF area types. But we want to go into more detail into that OSPF LSA type 7. Right, so what is actually the name of the type 7 LSA? Let's start off with something easy. So this is called the NSSA not so stubby area external LSA. Okay, nothing complicated there. Not so stubby area external link state advertisement, i.e. it is advertising external networks into a special type of OSPF area, i.e. an area that does not allow types 4 and 5 to actually exist in that area itself. The ABR and the ASBR just basically blocks those types of LSAs, types 4 and 5, and maybe type 3 if it's a totally stubby area. But an NSSA external LSA allows for these external networks to be transmitted through as that type 7 LSA. And what kind of information do you get in a type 7 LSA? It's really similar to the type 5 LSA, i.e. we still get those network IDs. We still get the subnet mask. We still get the cost. So a lot of people would probably say right now, well Dave, that's actually identical to a type 5 LSA. And yes, you would be right. However, with a type 5 LSA, it's either the cost is either going to be an E1 or an E2. By default, for all vendors, it's an E2. External type 2. We'll come on to the differences in a later video. Whereas for type 7, it is either an N1 or an N2, i.e. an NSSA type 1 or type 2. And again, I said this in a few videos ago, OSPF uses the Dijkstra algorithm to calculate the shortest path first. And there's different ways to manipulate that costing through the use of N2, N1, E2, N1, inter-area routes and intra-area routes. So that's actually order that OSPF prefers the routes from the least favourite all the way to the most favourite. The least favourite being N2 and the most favourite type of route is intra-area route, i.e. routes within the same area. So what you have to do, whether it be stub or totally stubby area, not so stubby area, is on the ABR we have to configure this to be a not so stubby area, and this has to be configured on each of those routers that are in the same area. Okay, you can't have one configured as an NSSA and the other not configured as an NSSA, because they'll identify via that type 1 LSSA, well hang on, VMX2, you're saying you're configured into a not so stubby area, I'm not configured into a not so stubby area, therefore our adjacency isn't going to form, it's just not going to work. So regardless, all routers in that same area have to have that same setting, i.e. stub or not so stubby area, obviously depending on the type of OSPF area you want to configure. Okay, the difference is on the ABR we then start to configure additional metrics, because again, remember, the ABR is going to block types 4, 5 from coming into area 2 from area 0. If it's a totally stubby area, it's going to block types 3, 4 and 5. For NSSA, it is still going to block types 4 and 5, but it's going to allow type 7s. But for the ABR, we then need to configure additional metrics. So these might be your default LSA, i.e. you want to advertise a default route. So this would be a totally stubby area, and then you need to define the default metric as well. Just going to put here M there, so the default metric. And there's other configurations you want to do. So a lot of the actual configuration is going onto the ABR itself, but all other routers in that same area, not so stubby area, totally not so stubby area, stub, totally stubby, they have to be configured for that stub or that not so stubby area configuration. That has to be there or the adjacency won't be formed. So let's actually go onto those routers and start this configuration. Right, so here we are on VMX1 in area 0. I've already logged in, but if I just do a run show OSPF database, what we should see, and we do, is our router LSAs in the same area for router 1, of course, router 2, router 3. We see our network LSAs, the summary LSAs that we're receiving from area 2 and from area 3 via the ABRs for those networks in between them all. And we're also receiving that ASBR summary. So that's that type 4 LSA that's really advertising VMX6 through ABR 2, VMX2. And we can also see those type 5 LSAs, which are the external LSAs via the advertising router R6, but which really is received and transmitted via the ABR. So the ABRs are very important. Basically, all information is there in our OSPF database. But this is very shortly going to change. So if I now just go, and that's just to show you that we have everything that we actually need. But if I go on to VMX2 here, and just to show you this, if I just do a run show OSPF neighbor, we can see we've got our adjacency to VMX1 and to VMX4. So 1111 is VMX1, 4444 is VMX4. Now, when I configure this to be a not so stubby area, we are going to see the adjacency is going to be lost to VMX4. Okay, so let's do edit protocols OSPF area 2. We have to define the area 2, because don't forget VMX2 is an ABI as interfaces into the backbone, into area 0 and into area 2. So make sure you define the right area. And now we want to define this as, let's do a question mark so you can see all the values, as a not so stubby area. So let's do NSSA, and just to show you what the extra configurations you can do, it's very straightforward. The default LSA, this is what I was saying a few minutes ago. So that's where we configure a default LSA, the default route to be advertised into area 2, and give it a default metric and a specific metric type. We can also define there to be no summary, so no type 3 LSAs will be advertised from area 0 into area 2. So then this would become a totally not so stubby area. Or we can actually define there to be summaries. So we are going to allow summary LSAs, type 3 LSAs, to be advertised into area 2. You need to do that. You can't just define NSSA here, because then from a Junos perspective, Junos is not going to know if VMX2 is an ABR or not. You have to define no summaries or summaries, i.e. you want to allow in type 3 LSAs, or if you don't want to allow in type 3 LSAs. So what I'm going to do is I'm just going to leave this as a not so stubby area. So I'm going to do set NSSA summaries. There's nothing else after this that you need to configure. You can also then just enter in area range, but we're not going to do this because we're not condensing or consolidating down specific ranges like 192.168, 101, 102, 103 into a specific unified address or address range. We're not doing that yet. We're going to do that on a future video, but not on this router as well. So if I now enter this in, and if I do show, we can now see that for area 2 ABR VMX2 is configured to NSSA not so stubby area. It is allowing in those type 3 LSAs. And if I just do a commit check, and that comes back and passes, so I'll just do a commit on this. And once this actually commits that configuration into Junos, don't forget is that with Junos we've got the running configuration and the candidate configuration, so you could do as many configurations as you want, but until you push commit, that configuration is not in the running configuration. But now if I do a run show OSPF neighbor, we can see that we have lost that adjacency to VMX4. And so you can see very clearly here that we've lost that connectivity, that adjacency to VMX4. And that is because, don't forget, I said that that NSSA has to be configured for all those routers in that same area, and it's the same for stub. If you're configuring a stub area, you need to have stub configured for all those routers in that same area, otherwise the adjacency just will not build. So now I need to go onto VMX4 and VMX6 and configure just the NSSA. I don't need to do what I've done here. I actually just configure the summaries or no summaries, etc., because that is the function of the ABR. The ABR is blocking those types 4 and 5s and maybe allowing those type 3s, or blocking them completely if it's a totally not so stubby or not so stubby area, etc. So let's go on to VMX4. I'll just bring it up, and I've not logged into this yet, so let's just enter in the password, and let's go into configuration mode, and let's do edit protocols OSPF I'm going to set area 2 to NSSA. Okay, and if I just quickly commit that, I won't go back to the ABR VMX2 to do this, but what I will do is just run the show OSPF neighbor, and what we should see now is that adjacency back up between VMX2 and VMX4. And there we go, we can actually see the adjacency is built from VMX4 to VMX2, but there's no adjacency from VMX4 to VMX6 because VMX6 doesn't have the NSSA configuration, hence the adjacency is not there. So let's just bring up VMX6. Here it is here, and I'm just going to run this over the top. Just logging in and CLI. Let's go into configure mode. Let's do edit protocols OSPF area 2 set NSSA show commit. And what we will now see once it says committed is if I come back onto VMX4, I'll just give it a few lines and run the same configuration. We have now got the adjacency rebuilt from VMX4, yes, to the APR VMX2, but now to VMX6. But how's that actually now changed from VMX1's perspective? Because don't forget, we saw those routes, didn't we? We saw, going back to VMX1, we saw all the advertisements here. Are we still going to see that? Well, that's actually a question for you. Are we still going to see exactly the same thing? And the answer is yes, you are still going to see exactly the same thing from VMX1's perspective, because don't forget, even though area 2 is now a not so stubby area and yes has type 7s going through it, those type 7s are stopped at the ABR and translated. They are re-advertised as type 5s and types 4 into area 0 and eventually into area 3. So everything outside of area 2, it will not see those type 7 LSA. So the real change will actually be inside area 2 itself. So if I look at VMX4 now, and let's just make the screen a bit larger, and let's just do top quit. I'm now in the operational mode, and if I just do a show route, show OSPF routes, I want to see all OSPF routes in the routing table, we can see the 192, 168, 101, 102, 103 exactly here. We could see that it's been advertised by R6, so the next hop IP address is 10.0.1.6. that is R6. That's great. We can also see the path type is external too. That is because the default behavior of an ASBR is to advertise it as an N2. You can obviously adjust that in the ASBR configuration to be an N1, but we're not really going to see much difference here because this is just a routing table. The routing table will take those best routes from the OSPF database and, well, it's actually the other way around. The OSPF database will import those best routes into the routing table. So we're really seeing here the best routes actually available to us, and obviously in this configuration there's not many routes are actually available. But if we do a show OSPF database, we can now see the NSSA, the type 7 LSAs. If you go back to the previous video, these were actually type 5 LSAs. We would have seen these as external LSAs. Okay, looks like in the virtual world we've still got some being advertised here as external, but that's more of a virtual machine issue than a configuration issue. It's not something I'm going to get concerned about. But we could see the NSSA's type 7s right here advertised by R6. So R6 is advertising the 101, the 102, the 103 network, and saying, well, if you want to get to these networks, you have to come through me. Here's my sequence ID. Here's the age, that's obviously max age, the length, etc. Now, if you want to go into more detail, we could do show OSPF database, NSSA, and let's do LSA ID. Let's pick on 192.168.101.0, and let's look at the detail within that. And as I said before, the LSA type 7 is similar to the type 5. really you're not going to see much difference here, but this type 2 here is an N2. If it was a type 5, it would be an E2. Okay, but the other information is absolutely identical. We see the network ID, we see the advertising router, we see the mask, we see the checksum and all that great information. Okay, but does VMX5 still have reachability? Can it still see these external networks? Well, if we actually go onto VMX5, let's just do a little test. And I haven't logged in here. And let's just do a show OSPF route. We can still see those networks here. Of course, we saw them in area 0. We saw them being advertised and received from area 2 into area 0 at VMX1. And it then stands to reason, if you've got obviously connectivity, which we do, the ABR VMX3 is going to change. It's going to summarize those type 4s and 5s it's seen through area 0 and transmit them into new type 4s and 5s and of course type 3s into area 3 itself. So we could see on VMX5 we've got the 101, 102, 103 network, and we can actually see, well, to get to these networks the next hop IP address is VMX3 itself, i.e. 10.0.2.1, 10.0.2.1, and these are external networks. Can we reach them? Let's do a ping 192.168.101.1. Now, if you recall to a previous video, we set these up to a reject, so there will be an ICMP response to this. So if I ping, we are now getting an ICMP response all the way through. So even though we've configured area 2 to be a not so stubby area, we still have that end-to-end reachability. The type 7s are not transmitted out of area 2, they're just summarized into a type 5, and that ABR VMX2 will also inject a type 4 to advertise. If you want to get to VMX6, this ASBR for these external networks, you've got to come through me. I'm the advertising router for that ASBR. Okay, so that is for a not so stubby area. What's so different with a totally not so stubby area? Well, if I come back to VMX2 now, and let's just get some space, and if I just do show, you can see I set NSSA summaries. I am allowing type 3 LSAs into area 2 from area 0. But now if I do set NSSA no summaries, let's do show, we can now see that it's changed from NSSA summaries here into NSSA no summaries. So no type 3 LSAs are then going to be, even if there's hundreds of thousands of them. Again, remember, we want to protect the routing table size, the CPU, the RAM, etc., and all the routers in here, because they might not be as capable as that in the core, in the backbone, in area 0. It doesn't matter how many of those type 3 LSAs, it's just going to inject one default route. So we also want to define a default route. So let's hit question mark, and I want to say the default LSA, and let's give it the default metric type. And now we could just define any value itself. So if you had two different ABRs here, you could define, and both are injecting a default route. You could give one with higher preference, one with lower preference, but the actual decision on where to send the packets for an external area is actually based initially, without manipulating metrics, is actually based on the best or highest router ID. But if we actually give it a metric type of 100, and if we do show, we can now see that we are not allowing any type 3 LSAs into area 2 from area 0, and we are going to inject a default route with a default metric of 100. Let's just do a quick commit check, and let's do a before and after. So if I just bring this to one side, and let's go back to VMX4, doesn't really matter which one, but if we go into VMX4, and let's do show OSPF route, just so we've got this information, and show OSPF database, just so we got fresh information before I commit it. And now on VMX2, if I commit that configuration, once that's actually committed, we're going to see some changes in VMX's 4's routing table and OSPF database. So that's committed, that's complete. I'll just get rid of this now to make the screen a little bit easier to look at. Let's give a little bit of space, and let's now run the last command. So what's the difference now? Well, the difference being is that we now have that one summary LSA. If we go back here, we had 1, 2, 3, 4, 5 summary LSAs, 5 type 3 LSAs. Now that's not much, of course, but think larger scale, think bigger network. This can very quickly ramp up. But because I defined the ABR to no summaries, it's then injecting one default route. Yes, I've still got the 3 type 7 LSAs coming from VMX6, which is the ASBR coming into area 2, but I'm now blocking, ABR is blocking, ABR2 is rejecting, not allowing through all those type 3 LSAs, and it's just injecting this one default route from the ABR, because this is VMX4's perspective. And if I actually go into detail now, into the summary LSA, so let's do net summary LSA ID 0.0.0.0 detail, and we can actually see that cost of 100. So recall back on the ABR on VMX2, I entered in that metric to be 100. If you want to use the default routes, it's quite a high cost. It's not the biggest, but it's a cost of 100. Again, it's the way you can manipulate costs within OSPF. But how has the routing table changed? So if I just do show OSPF route, we can still see everything, of course, within our network. You know, we've got our R2, we've got R6 identified via the type 1 LSAs. Of course, obviously the networks in between. The type 7 LSAs identifying those external static routes. But now and again, we've just got that one default route into network with a metric of 101. Why is it 101 instead of 100? Well, you've got to remember, the ABR is injecting all default routes from here into area 2 as a cost of 100. But VMX4 knows via the type 1 LSA, well, it's going to cost me 1 to get to VMX2. So 100 plus 1 is, of course, 101. And then from VMX6, it would be 102, because VMX6 knows it's going to cost me 1 to get to VMX4 and another 1 to get to VMX2, the APR. So 100 plus 2 is obviously 102. And that's going out of the gig 00 interface. So that is how we basically configure very easily Juniper Junos to have the OSPF special area type, or OSPF area type, or always call it special, not so stubby, and even very quickly at the end, the not so stubby area. And it's really not that much different for stub and totally stubby area. But stay tuned for the next video where I'll actually be covering an example of a bit more illustrative example, no configuration, as to why you'd actually want to do this and what the amount of routes that you'd expect to see on a bit more of a larger network than what we're actually using here. So thanks for watching and goodbye.